Hi there, this is Jacob Nash, Engineering Lessons, and this is Unit 2.1, Lesson 4 on um, how to do the 2.1.1 centroid calculations. There's 5 problems on the PLTW work, and I can show you how to do them. Now, something to note, the screen recorder that I'm using is Screencast-O-Matic, and you can see I obviously have the free version. That's why it has the watermark. That's the only thing I'm going to do for this situation, and it cuts off in 15 minutes. So if you see that this video is exactly 15 minutes, that means there's going to be 2 parts, and I think that's probably going to happen and so if it cuts me off, there's a second part. So watch the second part if there's one. I think that's what's going to probably happen. So let's get started. So we already figured out how to calculate the area of a rectangle, right triangle, and semicircle, and we also figured out how to calculate the coordinates for centroids. So now we can put that into effect and see what we can do. Now, I apologize if my handwriting's messy or delayed because I'm using some strange thing. Like, you should see my computer's like set up really weird. But anyways, so the first problem, it we've got a rectangle for this one. So let's try to draw it here. Let's see, did that show up? Yes. And if you're wondering, yeah, I'm one of the few people that are left-handed. That's just how it is. And let's see, what do we have here? We have a height of 0.5 inches, and we have a base of 0.75 inches. And it wants you to figure out where the centroid actually is. So the first thing we need to do is find the coordinates. We don't even have to find the area for this one. That's only when you're doing the crazy problems, the complex centroids. This is a simple centroid problem. So let me see how I can do this. Okay. So remember our formulas to find the x and y centroid coordinates. You need to do base divided by 2 and then height divided by 2. So we said our base was 0.75 inches. We divide that by 2. Then our height was 0.5 inches. Divide that by 2. And we ended up getting a final answer of 0.375 inches for the x coordinate, and for the y one, we have 0.25 inches. By the way, that line we put over the x and y, that's just what we do for this situation. Don't be confused by that. So these are the coordinates. So what we have to do is, well, we know centroid's always going to be in the center, so we can already draw the centroid. It doesn't have to be to scale unless you're on a graph. There is no graph for this one, so it's okay if it's a little bit off. So for the x, we said that was 0.375 inches. And then for the y, it was 0.25 inches. So that's number 1, and that's what it is. Now, hopefully you're not just coming here for the answers. Hopefully you actually figured out what I did there. Oh, I noticed that it's frozen a little bit. I'm sorry about that. And hopefully you can actually read what I did. But now we have, let me actually, that's not good. Never mind. So now we have the second problem. This time it's a right triangle. So I don't need to put the right angle there, but that it is a right triangle. So we have a height of 1 inch, and then we have a width of 0.5 inches. So our formula, I was about to say area, sorry. Our formula to find the x and y is base divided by 3, height divided by 3. So let's substitute and figure out what that is. So that we put in 0.5 and then 1. That turns out to be approximately 0.17 inches for the x, and for the y, 0.33 inches. Once again, estimate where the centroid would be. Then you draw the x, which is 0.17 inches, and then the y, 0.33 inches. That's it for that one. Now, for the third one, we have once again a right triangle. So let's draw that. And this time we have a height of 8 inches. Sorry. And then we have a base of 3 inches. Once again, we do base divided by 3, height divided by 3. So that's 3 divided by 3, and then 8 divided by 3. Our final answer turns out to be 1 inch for the x coordinate, and for the y, approximately 2.67 inches. Again, you estimate where the centroid would be. You write 1 inch and then 2.67 inches. That's number 3. Now for number 4, let me see. Oh, that is a semicircle. So let's see. Is that on there? Okay, yeah. 4. Okay, we got a semicircle here. And this time we're given a diameter of 20 inches, and we're given a that's all we're given. Yeah, that's all we need. Sorry. So the formula to find the centroid of a semicircle, remember it can change based on the way it's orientated. So since this is pointed vertically, we're going to need to use the x to find the x. In this case, we need 4r divided by 3 pi. R means radius. And then to find the y, we need just the radius. Sometimes you'll see that listed as base divided by 2, but that's the same thing. Well, in this case, it would be height. So how you can actually tell is you can see that this is the y direction, up and down. And that's the simpler part. It's not curved. That's why it's the simpler formula, which is just a radius. But remember, if it was turned this way, then instead you would use the radius to find the x and this to find the y. Okay, so we can plug it in. 4 times, you gotta be careful, 10. Why? Because that's the diameter. And to find the radius, you divide the diameter by 2, and you get 10. Then you do 3 pi. Sorry, messed up. Now, when you're typing this in a calculator, you might get a wrong answer, but you need to type it in like this. 4 times 10, you probably know that's 40. Then you hit the divided by slash sign. Then you have to do open parentheses 3, another open parentheses 3.14, and close that one, and then close that one. If you don't put that into parentheses, what it will do is say 4 times 10, which is 40, divided by 3, and then multiply that by pi. That's not what you want. You want that to be multiplied by itself first. So, for the final answer, we get what was it? 4 point, yeah, 4.25 inches. That is for the X. And remember, the Y is just the radius, which we said was 10 inches. So the coordinates are 4.25 inches, 10 inches. And then we estimate where the centroid is. And there you go, 4.25 inches. And then you have to bring that all the way down to this line down here, not just the edge, for 10 inches. Or you could just draw the line there. That is 1 through 4. And you know what? I decided that I'm going to actually make another video myself because I know I can't fit number 5 in by itself. So, because number 5 is the complex one. So now I'm going to end the recording and you should see part 2 to solve number 5. Thank you for watching.